Assalamualaikum. My name is Abdul Ali Aiman bin Azhar. My metric number is 2019584477. And today I would like to present my research is about comparison between different types of foot archers in relation to power among Malaysia women's field hockey athletes. Okay. For the background of the study, the foot is divided. First of all, my independent variable is the foot is divided into three categories depend on arc height. And next, my dependent variable is power. Power, which are power are most important physical attributes, especially in jumping movement, acceleration, and throwing. They are pass planners, normal pass cavers of foot types, which are high, normal, and low foot arches. Okay. Based on the research, it may be the arc height influence the force acting between foot and ground. So, as you can see, so my main target population is among Malaysian women's field hockey athletes. They are consistently involved in physical activities which requires them to have a top-notch power. Okay, moving next to the statement of problem. Okay, there is a limited research found on foot biomechanics that related to power, especially the type of foot arches. Furthermore, the relationship between types of foot arches and power component among Malaysian have not been established, and this is becoming needed for the present study. This study is trying to prove the which type of foot arches give better result in power by highlighting the relationship between the types of foot arches and power of Malaysians women field hockey athletes. Okay, let's moving to the next research objective. Research objective first of all to determine the type of foot arches of Malaysian women's field hockey athletes. Next, to determine the power of Malaysian women field hockey athletes. And the last one is to compare different types of foot arches in a relation to power among Malaysians women's field hockey athletes. Okay. Moving next slide for our literature review. The human foot is a complex anatomical structure which consists of multiple bones, ligaments, and muscles. So, human foot posture is generally characterized by the alignment of the foot skeleton and various considerable between individuals. So, foot arches is categorized into three using the morphology of the medical arc, which are high, normal, and low foot arc. So next is we're moving to my DV which is power. So next, muscle power combines strength with speed and movement coordination, basic characteristic for performing basic daily tasks and preventives. So power produced by the joint of body can be determined by the product of the neck joints, torque, and joint angular velocity. So we're moving next, the relationship between two of foot arc and the power. So the relation between type of foot arc and power have uh, less evidence from previous studies to reveal that athletes with high arc foot have better power when compared to the low and natural arc foot. But in the studies, the energy sparing spring theory of foot arc has become central to of the foot arc mechanicals function and evolution. So in the studies shows that there is a relation to the compression and subsequent storage return of elastic energy in foot's longitudinal arc affects the metabolic cost of locomotion. So we're moving next to our methodology. Okay, for our research design, first of all, we have descriptive and casual comparative. So the descriptive casual comparative research design will be used in the study. So this research design is suitable with the research objective, which is to identify which type of foot up shows better results in power. Okay. Research questions and hypotheses of the study have been taken into to align the selecting design of this research. So, for casual comparative, design will be used as this study to compare the independent variable of the type of foot arch and power which in the dependent variable that have been in between the different groups of high, medium, and low foot arc. And the independent variable in the study cannot be controlled. So the result of the study will be analyzed from a one-shot data collection to control extraneous variables, in descriptive. Okay. Okay. Moving next, for sampling size. So the number of population is known with a total of 30 athletes from multiple positions in the Malaysian women's field hockey team. However, 5 of the athletes were removed from the list as they were quarantined and were not present in the training camp during the test period. So the study was then conducted on 20 nationals women's hockey athletes as 5 subjects were removed due to injury occurred in the training session. So total of 20 samples will proceed according to the variety of the test subjects. So, okay, moving next, the sampling technique. Okay, purposive sampling of the non-probability will be the sampling technique used to collect the samples from sample size estimated as they cannot be selected randomly. So samples with BMI in a predetermined range will be selected to limit generalizability. So their BMI range should be in between 18.5 to 24.9 to maintain the reliability of test of the results. We're moving next. Okay, to the instrumentations. So my independent variable is type of foot arch. So the test will be the wet test. So the instrumentation is the water is poured in a pan, so that fit the foot of the athletes, and the water is deep enough to well all parts of the bottom of the foot. Then the subject will step into the water with one foot, then carefully remove their foot from the pan. Next, they will step onto a cardboard and put their weight on it. And finally, the foot is removed from the cardboard and leave a mark of a footprint to be taken a reference, and this process will be repeated with the subject other foot. Okay. For the next, my dependent variable, we using counter movement jump test for power. So the first of all, in this procedure, the athlete needs to step on the platform and must keep their hands on the hips throughout the test. Then the athlete must jump as high as possible and attempt to land in the same location on the platform as they take off from, because jumping forwards, backwards, or sideways can affect the test of results. So during their time spent in the air, it is essential that the athletes maintain extension in the hip, knee, and the ankle joints to prevent the achieving any additional flight time by bending their legs. So, and the athletes must perform a minimum of 3 jumps, so the performance average can be calculated. So this is the data collection procedure. So for data collection procedure, before starting the test, informed consent forms will be given and should be filled by every participant. Participants should be at a good health condition and free from injuries before doing the test. Their BMI will be measured and recorded to make sure they are in the same range. The type of foot up will be measured by using the wet test. Then the test is determine subjects types of the foot arches before assigning them into the different groups. So next, subject will be do the counter movement jump test for the power. And finally, the data collected will be arranged according to the subject's type of foot arcs and then analyzed to identify which type of food art shows better result in power. Okay, moving next to our data analysis. So, this objective to compare the different types of foot arches in relation to speed among Malaysian women field hockey athletes. So, the data analysis using ANOVA. So, IBM SPSS 25 will be used to analyze the data to compare the different types of foot arches in relation to power among Malaysian women's field hockey, and the descriptive analysis will be used to collect the data needed in order to analyze the mean, and descriptive analysis will be carried out using mean, SD, standard deviation, while inferential statistic will be conducted to seek a difference between group of high arc, normal arc, and low arc foot. So, analysis of variance, which is ANOVA, will be used if the data distribution of three groups were found to be normal, while Kruskal-Wallis will be used if the three groups data distribution were non-normal. So the data that have been collected will be compared to every group to get the significance of the study, and the statistical significant difference will be set at alpha p above 0.05 with alpha 0.05. Okay. Moving next to the results. Okay. Normality distribution. The normality of the data was determined through the significance of Shapiro-Wilk, as the total data collected were only 20. So as you can see, the normality of the data determined through the significant value of Shapiro-Wilk, as the total data collected were only 20. So state at the Shapiro-Wilk test is a more appropriate method for small sample size or samples of 50 and less. So the data can be considered as normal distribute if the significant value of Shapiro-Wilk is more than 0.05. As you can see in the table, represent the normal distribution result for all variables. Recorded result of Shapiro-Wilk are more than 0.05 on all groups. Therefore, the data from this study were assumed to be normal distributed. As the Shapiro-Wilk showed the data distribution was normal, there is no need for kurtosis to be referred. Moving next, the descriptive analysis. The study was conducted on 20 national women's hockey athletes, were all of them passed the wet test, and which each subject was required to fill the demographic segmentation of age and playing position, and the data has been analyzed. Based on this descriptive statistic in the table, the mean age of the subject is 22. The subject age in a range is between 18 to 35 years old. All subjects were female. Also shown in the table, the mean power was 36.8, deviation of 0.85 centimeters. With the highest jump recorded was 44.7 centimeter, and the lowest was 29.7 centimeter. Then the mean of the BMI was 21.55, with all of the subjects being in the predetermined range of 18.5 to 24.9. Maintain to maintain the reliability of the test result. So for the type of foot arc, 4 of the subject possess high arc, 12 of them are normal, and while 4 others possess low arc. So moving next to our inferential analysis. As the data were declared as normally distributed, the parametric test of analysis of variance ANOVA was conducted to compare the height jump of counter movement jump between the three groups of height, normal, and low arc to determine which type of foot arc shows better result in terms of power. The result of the test revealed that P value is less than 0.05. So more than 0.05. P, which the result is 0.391. Thus, the null hypothesis was failed to reject. So therefore, it was concluded that there is no significant difference of power between the three groups of foot arches. Then we moving to our next discussion. In our discussion, comparison between different types of foot arches in relation to power among Malaysian women's field hockey athletes. Finding from the previous study have led to the hypothesis making of this study. So although power is influenced by many factors, there are studies that prove that the arc height index of athletes can actually affect power. But based on the outcome of this study, it was concluded that there is no significant difference between athletes who possess high, normal, and low arc on power. Hence, which type of foot arc shows better results in terms of power could not be determined. So the result might be caused by the uneven distribution of data in each group. And the small size of samples might be one of the reasons that we could not receive the expected outcome. So even though in it is shown that the type of foot arc may be related to the power, other key factors that could possibly influence the result has been considered. So, other factors. First of all, muscular power. This includes the jump or other factors, muscular power and type of footwear. So, these include the jumping mechanics, muscle composition, neural influence, and environmental condition. But one of the reason is muscular power plays an important role in determining the jump of an individual. So the power produced by the joints of the body can be determined by the product of the net joint torque and the joint angular velocity. So although subjects body index BMI was in the predetermined range to limit generalizability of the test result, muscular power of athletes, especially their lower limbs, are different from each other. So field hockey, as you can see, athletes were used to train based on their position that might have different type of power needed compared to such as a goalkeeper and attacker. And they are moving all around the field in constant condition of bowing low and holding stick. So every position have different type of power needed. So in addition, found that there are difference of the hip angular velocity between constant and free running profiles during sprints that may can impact their power. So other factors is type of footwear. Other than that, the type of footwear used by athletes during the test could also be factor one of the test outcomes. So as found in a research, the type of footwear has some effect on the athletes. All of the athletes, when during the test, were wearing the training shoes. Most of them did not know their type of foot arc and when they're buying or using the foot training shoes. So in previous research state that the wearing unstable shoe for specific arc could result in stiffness, which would probably affect performance. So despite all these factors, it can be seen from the raw data that some athletes can jump high even with low arc, and some others jump low despite having higher arc, high index. In my conclusion, to conclude this study, it was found that there is no significant difference between high, low, and normal foot arches in relation to power, even though previous studies have concluded it differently, but the outcome from this study were not able to prove it. Other key factors that influence power might have affected the result. However, improvement could be made in the future to see different findings. So my recommendation for this study, to improve the clarity of result in the future studies, it is suggested that the researcher collect more data from bigger and sample size to prove that there is significant difference between the type of foot arches and power. Number of the subjects, each group could be even to control the normality of the test result. It is important to make sure the subjects are wearing suitable shoes during the test to make sure the result and varied. This include the use of specific insoles for low arc to make sure the footwear used are uniform. The use of BIA could be helpful in helpful to further limit the generalizability of the test result, and perhaps future researcher could integrate specific equipment constraint to replicate the mechanical demands of a specific sport. That's all from me. Thank you.